Good morning. My name is Joy, and together with me are my teammates Pratap, Tangesh, and Sulang. Our team is proud to present to all of you our final presentation for Cloud and Big Data Analytics final project. Our team is Team 2, and we have decided to touch upon this dataset from the GDELT project website. One of our teammates has suggested to take upon this dataset from GDELT website, and in terms of big data, definitely this dataset has been the largest, most comprehensive, and highest resolution open database of human society ever created. So our team then has agreed to proceed and use this dataset. Supported by Google Ideas, the GDELT project monitors the world's broadcast, print, and web news from nearly every corner of every country in over 100 languages and identifies the people, locations, organizations, counts, themes, sources, and events driving our global society every second of every day, creating a free open platform for computing on the entire world. In addition to the translated domestic news materials, the historical backfile of GDELT makes extensive use of the following online sources, like the Washington Post, CPI.com, BBC Monitoring, African News, AFP, Facts and File, Christian Science Monitoring, and the rest. So the first challenge the team came upon with is actually importing the data into Jupyter, where we plan to basically do the analysis. Unlike before, we can just easily upload the file in Jupyter or put the file in S3. This time around, the data is really too big and our team would need to really spend a few dollars if we plan to use the AWS.
So about the data. The data is located on Google BigQuery, and this data set is around 124 GB in size and around 350 million rows. The data is located in US and is updated on a real-time basis. So we import the data from Google BigQuery into Jupyter using in the following steps. First, we configure the BigQuery, then we set up the API credentials, then we aggregate data on the cloud, then we configure Docker. After that, we store the aggregated data to go ahead and process the data. So these are the tools and services used for the project. It's pretty simple: Google BigQuery, Amazon EC2, and Jupyter. Below is a snapshot of the code that connects all these three and which helps us import data from Google BigQuery. So the local system versus cloud. As you can see, the local system has limited limited resources, and cloud has nearly unlimited resources. What we have used is 24 GB of data, 30 GB of memory space, and 1 core CPU, and the time required to download data was just 3 to 5 minutes. We actually leveraged Google's BigQuery capability to import data without incurring cost. Had we done this analysis on EC2, it would have costed us $2.50 an hour because given the size of data. Since we used Google BigQuery, we actually done this analysis free of cost.
Taking on from Pratap, as we can see, we've done a past use of lateral analysis for the last 15 years, and we have noticed that there has been an exponential rise in the number of articles that are being published, thanks to social media and upcoming digital journalism across the world. And in this graph, we can notice that the primary media houses are located in North America, Europe, Russia, India, and China. And undisputably, North America contributing to most of the articles around the world, even across borders, which tells us that the social media impact is very huge in North America. In this graph, we are able to see the top 1,000 newspapers, which indicates who is talking about whom, and from this graph we can observe that in the recent times there has been more emphasis on the terrorist talks around the Middle East countries. Hello? Hello?
Yep.
Who's supposed to do the...
So for this one is tomorrow evening this part will be discussed by Pata.
No, I think it's language.
Oh, okay. Then let's proceed first with the architecture then.
Okay, as far as the architecture is concerned, we use almost all of Amazon's properties, starting with root S3, which takes care of the DNS, and then we use S3 to store the static resources and elastic load balancing to maintain our EC2 modules which communicates with the BigQuery master database from Google. And all of them, they have the potential for autoscale. The biggest challenge we face is the size of the data itself. The sheer size of being almost 130 GB large, adding to the complexity and resource consumption. For each query, we spent around 3 to 5 minutes waiting for the results, and even this result was not directly processable by Jupyter. Hence, we need to aggregate the data before we process them. The other big challenge is the structure of the data itself. The data is highly unstructured, meaning that the entire database consists of a lot of null values and blank entries, which we need to accommodate for in our code so that we don't end up with graphs like these.
So digital media now represents around $160 billion, and this space is growing exponentially, contributing to 32% of total sales. So this analysis serves as a market research for all the media houses who want to expand their business.
So at the end of this, the team believes that we still need further exploration as to how we can further make use of the data. There will be a lot of articles showing more about this large data set and on how it can help, not just with cloud and big data academic stuff, but more of example how it can be used to also analyze multi-level of peace and conflict. So if you are interested in the challenge, join our team and together we dig up this big master of data and see how we can contribute further to the betterment of the society and perhaps the whole world. Thank you, that's all.
Thank you.